try not to crowd your work like I'm doing. Because when you crowd your work, it's much easier to make careless errors. Alright, well, the perimeter is a function p of x, and it would be 3x plus 2 parentheses 100 minus x squared over x plus, and I need to erase in order to make room for this square root. So let me erase my my expression for y there. Plus the square root of x squared plus, and alright, here we go. It's going to be bracket 2 parentheses 100 minus x squared all over x, close bracket, squared. So this is y squared from here. Alright, so let me, and this is in inches. Okay, IN for inches, or you can spell it out, doesn't matter to me. But perimeter is in inches. And do you see the inches here? X is in inches, so there's 3x inches. That's square inches, but when I divide square inches by inches, I get inches here. Here's square inches. Here's inches squared, those square inches. So you add square inches to square inches, you get square inches, but when you take the square root of that, you get inches. So that's in inches, that's in inches, and that's in inches. I just wanted to talk through that because it's true. I mean, the units have to be consistent in this function in order to be valid. If I had inches plus square inches somewhere, then it would have to be wrong. And so here's my function. There we go. So a little bit ugly looking, I would say. It might be possible to simplify that a little bit. I don't know if it really could be simplified or not. So in hindsight, I've never worked this one before, but this would make one heck of a calculus problem, because that's the next question is, well, how can I do this with the smallest perimeter? For example, the least amount of materials to build this object. What would x have to be? And I would have to work some calculus on this. So I haven't done that, and so I can't tell you off the top of my head. It's looks like quite a problem to solve. But anyway, that becomes the next question, which is part of that motivating factor is why we study these this mathematical modeling. But we have to leave it here because we haven't done calculus. So there we go. Now, just to recap again, I told you I wanted you to concentrate on this whole technique. Not get too bogged down with the algebra, but the technique that I just drew a picture of my problem. I described it in terms of my variables. I had to define variables. X was my base, Y was this height of the rectangle here. And from that, we were able to write out a calculation for perimeter. We want a function describing perimeter. Okay, so I wrote out the perimeter calculation, but we wanted to put that in terms of a single variable, the base. So that meant I had to use this information, the area information, to solve for y in order to substitute in and get this function of a single variable. That is, that was the gist of this problem, and it's actually quite similar to a lot of these problems where you're going to have to take some given information and solve for one of the variables and do a substitution. And after you do a good handful of these, they'll start looking pretty similar to one another.